For each of the following, determine whether the equation defines y as a function of x. So to do this, we just solve for y and see if we end up with a single value in terms of x. For a, y minus x squared equals 2, all we need to do is add x squared to both sides. And we do that, and we end up with y equals 2 plus x squared. Notice that y is completely unambiguous here. Okay? If I were to plug in a value of x, I would know exactly what y is. And therefore, this is a function of x. So y is a function of x. For b, x squared plus y squared equals 4. Again, to solve for y, first we'll subtract x squared from both sides. That gives us y squared equals 4 minus x squared. But then, to get y by itself, we need to take the square root. Well, when you do a square root, you must also do a plus or a minus, because if you square a negative, you can also get the positive. And so, taking the square root of both sides, we get y equals plus or minus the square root of 4 minus x squared. Well, y here is kind of ambiguous. We don't actually know what it would be for a given value of x. For example, if you plug in x equals 0, you have plus or minus the square root of 4. Well, that's plus or minus 2. But which one is it? We don't know just by plugging in a value of x. There would be two different values. Therefore, this y is not a function of x. Y is not a function of x. And for part C, the square root of y plus the square root of x equals 4. So again, we try to solve for y. We'll subtract the square root of x from both sides here. So we have the square root of y equals 4 minus the square root of x. Okay, now to get y by itself, we will square both sides. Now, squaring both sides is not the same as taking the square root. So when you square both sides, you do not have to do a plus or minus. So we square this, and now it is completely unambiguous as to what y would be when I plug in an x value. Therefore, y is a function of x.